Yeah, I've just said yes.
Yeah, just started. Yeah,
Okay, cool.
just started.
Just started recording. Fantastic.
All right. Well, hello and welcome to AU Manufacturing Conversations, where we dive deep into the minds shaping the future of the industry. I'm your host, Simran Gill, and today we're thrilled to have Ayrton Sue from Element Engineering with us. Ayrton, thank you for joining us.
No problem at all. Thanks for having me on.
You've been a pretty significant mover and shaker in the local manufacturing sector. To kick things off, could you tell us a bit about your journey to this point and what your company specializes in?
Yeah, thanks for calling us a mover and shaker. I guess I'm just doing what I feel is good for the industry and also good for us. But yeah, it's been a long journey for myself. I always grew up around manufacturing. My parents had a driving school business, one of the oldest driving school businesses in Perth, called Kensington Driving School, and we grew up around cars and motorbikes and trucks. So I've always been pretty hands-on. And my first job was at the local beach buggy manufacturing place in Malaga, here in Malaga, just down the road, and they were manufacturing space-framed beach buggies that had Briggs and Stratton engines and were exporting all the way over to the Middle East and all around the world. And it's pretty awesome to grow up around that sort of stuff. And my first job, sweeping the floors and helping out on weekends and things like that, just sort of inspired me to stay hands-on. I always wanted to be a machinist, but sort of got the opportunity to go to university. And even while I was at university doing mechanical engineering, I still worked in workshops, which was heavy boiler making, sheet metal trades, just general fabrication sort of stuff. And yeah, it sort of grew from there. Through the engineering degree, I did the motorsport team, which was sort of kind of pivotal to my career, I guess. Got to play with everything from general fabrication through to carbon fiber, manufacturing carbon fiber, designing it, of course, and also then the things that I was seeing and the way that they were shaped, I could actually validate them with the engineering. So we won at University of Western Australia won the Formula Student or Formula SAE World Championship in 2008, and I was part of that team. And we got, everyone got interesting job offers from different places. I sort of left university around 2009 and then jumped basically directly into the local manufacturing industry here in Perth, utilising the skills that I'd sort of built up over those years, and basically utilising the engineering skills also with the fabrication skills, working for a large haul-pack truck tray manufacturing company. Also sort of worked with data loggers, the data logging systems that we'd worked with in the motorsport team, and we were using them on the truck trays. And also going back a step as well, I did my thesis on the design and manufacture of haul-pack truck tires, so heavy industry truck tires, which is a complete art of its own. And got the opportunity to work up in China, between Australia and China, and see the massive manufacturing that was happening up there. So the data loggers were being used to find the forces on these different structures, whether or not it's a tyre and the heat generated, or a truck tray and its vibrations. We got the opportunity to work with other companies where we're doing the same. And yeah, the business kind of just grew out of that, where we basically were doing quite high-end design, real first principle stuff. So going back to basics, what are the actual loads coming in, doing it in a different way using data that was coming from these data loggers, and then optimizing the design of these structures. But as part of the manufacturing piece, given my hands-on experience that I've always been around workshops and fabrication and things like that, I was kind of a center point for taking designs and making sure that they get manufactured in the workshops, making sure that the things or the drawings we were putting out were actually going to be used, making sure that the designs that we were creating were actually being fabricated, and then the feedback from site, feedback from the actual performance in the field and the end user experience was getting fed back into the design phase. So yeah, that was kind of the early days. After that, we Element Engineering started off as a couple of myself and a friend of mine who was a draftsman, sort of my business bringing him in to sort of help with the workload. And then we picked up a number of different contracts with different companies all around the world. And the electronics side of it has always been a passion of mine, especially through the data logging and data analytics. And that's where we got into sort of electronics. Electronics has always been a hobby, but it turned into a bit of a profession. And that profession was driven out of need to create our own data loggers that basically could replicate what we were doing with these off-the-shelf data loggers, but they were very expensive, very cumbersome, took a lot of effort to put together, and then a lot of effort to sort of interpret the data and understand and how to use that data. So we went off on this sidebar tangent to create our own data loggers. We had some very good success with that in the early days, so 2014, 2015. We had some trials down at a mine site in the southwest of Western Australia. And then from there, we got introduced to a lot of the big companies, resources companies locally, where they saw our unique application of data acquisition, utilising smart sensing or edge computation, those sorts of things, and then using that information as feedback for refinement of whatever mechanical systems that they had. So we've gone down this path of learning all these skills, but at the end of the day, being able to create products with the end user in mind. And through that process, we've touched nearly every manufacturing process that I can nearly think of, especially in resources, but also in consumer products, also in other products in mining, oil and gas. There's lots there.
So I suppose tell me a little bit about what you do as if I was a 5-year-old.
We're a product development and innovation company. So we basically look at what the end user wants from a product, and we look at the available manufacturing techniques, the available technologies that are available to use, and we lean on our experience to basically put together a commercial product. That can be from total concept of something that's completely not done, or it could be an iteration on what a client currently has. So because we've got a wealth of experience in different manufacturing techniques, and we kind of operate at the cutting edge, not the bleeding edge of most technologies, we can do many things in many different domains. So our core has started off in mechanical, how do we manufacture things or make physical things, electronics to basically strap on sensors and actuators to a mechanical system, and then how do we use software to be able to give that machine or structure a voice, and give the user the end result that they need. So that's basically the core of the business.
Okay, and what's the coolest thing that you guys do?
The coolest thing? The coolest thing that we do would be taking someone's idea and turning it into a fully fledged product. That is much harder than most people would think. I think the coolest part of that journey would be helping a customer really understand what the product is and what the potential pathways or engineering pathways that could be done to make it commercial and sustainable. So any product can be made in any number of ways. There's different ways of doing things if you're going to do a 1 of, 10 of, 100 of versus a high volume 10,000 of product. And I guess that's our skill and our art, is sort of knowing the different manufacturing techniques especially, and then engineering the product around the available manufacturing techniques to give the end user what they need.
And what's a product that I guess you've made from scratch then?
I guess the Shockwiz was the first one, with Nigel Wade. He's a friend of mine from university who had a very awesome idea for a mountain bike suspension tuning widget, and he had the algorithm and a good concept of what the mechanical, electronic, and software arrangements would be. But we really we partnered with him. we basically put all of the engineering together to come up with a Kickstarter, took that through the Kickstarter, and then after we launched the Kickstarter, Nigel sold the rights to it to a company called SRAM, who make a lot of high-end bicycle components for a lot of the large bicycle companies in the world, and that was a great process because we got to do it to a really highly commercial level, proper consumer product with all the polish and demand, to achieve the demands of what consumers want, because consumers are really, really hard clients to have. From that, probably the Tyre Whiz 2, so it's again another consumer bicycle product where we were given sort of an original product, the first version that wasn't quite hitting the mark in regards to its manufacturing cost, and also had some challenges in COVID, hangover from COVID, with electronic chips that weren't available. We were able to massively decrease the manufacturing cost to the point where it actually exceeded expectations, and that was all due to doing the engineering process properly, basically, and eliminating parts of the chips that were available, or weren't available anyway, and really saving the costs so that the volumes could really go up. So they're two of the biggest ones I think we've done and the most successful, but we've worked on other things as well where they might be truck trays for DT Highload Australia back in 2009, before we opened the business. To see that business flourish from basically the SolidWorks designs that I was doing. They were struggling with turning around quotes in weeks. I was able to make a SolidWorks CAD model system that basically they would change a few dimensions, and a quote or even a full set of production drawings would pop out in days, not weeks. So that really made that business flourish from a few tens of truck trays a year to hundreds of truck trays a year within only a couple of years. So those sorts of projects are really rewarding for me, is when there's an idea or a challenge, and we can come in and utilize our experience and utilize the skills that we've learned, or the interesting engineering techniques that we have built up over the years to give the customer a real big kick out of providing a new product, or massive cost savings, or more sustainable, or things like that. So they're the things that kind of get me excited, I guess.
Yeah, that sounds really cool. So obviously along your journey, could you tell us a bit about a couple of pivotal moments that really shaped your career? Like what made you get into manufacturing in particular?
The first one really would have to be leading up to COVID, I guess. We've always used overseas suppliers for element engineering. We had a very good plastic injection molding company we were working with for consumer products, effectively, where we were designing consumer products, and we would liaise with the factory. They were based in Shenzhen, and we would have great backwards and forwards communication, be able to iterate on design ideas and change our design to best fit the molding techniques and things like that. That process started to slow down around 2018. I don't know whether or not it was because of local demands, but in 2020 with COVID, the communication was almost non-existent, and we struggled to keep up with the demands from our own customers. We were doing all of our prototyping and low volume production, so the initial batches of prototypes that we would put out to market was all being done overseas, and that became harder and harder and harder, and we felt we were letting down our own customers. So between 2018 and 2020, we really started to look into our own manufacturing in-house, first of all to supplement or to replace what we were sending overseas, and secondly to do it better as an engineering company. So we really wanted to understand those processes rather than just being the engineer that sends the drawings and then liaises with the manufacturer. We actually wanted to understand what the manufacturer was going through and how we could be better engineers, basically. I've always been the engineer that does the designs and then liaises with these factories. I've done it in China, mainland China, Shenzhen, Taiwan, and the US, and the collaborative, highly collaborative, and conversational nature is really inspiring. It's really awesome. So I really wanted to bring that back to Australia effectively, because I've not had, really unfortunately, not had that experience here in Australia. Nowhere near what I've seen overseas, especially in the US, Taiwan, and China. So yeah, that was a big one. I think there are other ones as well. Working in America in consumer and industrial type pressure sensors with a company over there. That was sort of from 2012 through 2014. Just being able to go to Kansas City, and then you drive 45 minutes out of Kansas City and you go to a big barn in the middle of a cornfield, and you walk into it, and it's the most amazing, highly technological, contract manufacturing, electronics contract manufacturing place that I've ever seen. Again, was inspiring to me, because if they can do it in Kansas City, why can't we do it here in little old Perth, in Shenzhen, middle of Shenzhen, or right in the backwaters of China, going to Taiwan and places like Gigatech, where it's like 5 stories of contract manufacturing, and we're installing a production line for SRAM, and right behind us, the production line that's behind us is Google working on their product, and the cost of living, as far as I understand, for educated individuals is pretty high over in these places. So my real driver for this is kind of saying, why can't we do it here? And given that I'm being the guy who goes and liaises with those people and gets the product into a manufacturable state, I'm really trying to push to have those challenges here and do it even better, and try and find those economies and do it locally.
So you touched on that collaborative environment that you admire from like China, if I remember correctly. So do you think that you have recreated that within your own company as it is now, and how do you hope that will develop as you guys develop?
Yeah, I hope that we have not only recreated it, but we've improved on it, I guess. The usual process that I've gone through is, you send some drawings, you call up your supplier, tell them that this thing's coming, send a drawing pack, and then they will, in a collaborative way, get on a video call, phone call, go through the drawings, go through the little details, those sorts of things, and then give feedback, probably get a preliminary quote, and then maybe make some changes for design for manufacture, make it better for them to manufacture, make it cheaper, faster, and everybody wins, right? That has not happened in my experience in Australia. It's just, you send a quote out and you may or may not get quotes back. Post-COVID, we had a client who was really looking for software manufacturing, and they said, no, it's got to be all from Australia, even though we were doing everything in China before that. And they sort of said, let's get quotes from all of the best places we can in Australia. We sent out for 13 sets of quotes to reputable companies, a lot of them here in Perth, and quite a few reputable companies in over east. We only got 3 quotes back, and not one of them had any initiative or opportunity to basically have that collaborative conversation where we jump on the phone and say, hey, look, we're just trying to see if this is in your wheelhouse. Let us know if there's anything that sticks out to you. Let's work on this together, and let's really, because we want to kind of partner with you for the production. So in our own business, we're really trying to replicate that, but even earlier on in the design process. So as the engineers are doing the work, we want them to be addressing those design for manufacture processes with the guys on the workshop floor immediately, and not getting to the point where they might have a somewhat finished design where they do some drawings, they send it off, and then they basically have that collaborative backwards and forwards at that stage. We want to try and have it really, really early on, and it also have the guys, the engineers, trained in the best manufacturing process or the best design for manufacture as early as possible. So that's the aim. It is very hard to do. It means there's a lot of internal training and cross pollination. There's a lot of conversations that need to be had. It's highly collaborative, and I feel like these days collaboration has become a bit of a dirty word. It's things that salesmen talk to us all the time. Oh, let's talk about collaboration. Well, real collaboration to me is conversations through the process, and everyone learning on both sides as we go, not just trying to sell something, right? So I feel that that's the real aim here. Is first of all, bringing these manufacturing processes in-house really is number one to make us better engineers. Secondly, it gets designs done way faster than we ever did before, and hopefully we can pump out the prototyping and small batch production runs to get a product to market much faster than we were before. And thirdly, we want to try to provide a manufacturing service that can basically rival the best of what we've seen overseas. Not saying that there's obviously amazing manufacturers here in Australia, but if we can provide that highly collaborative approach that we've seen from overseas, as well as the high quality and fast turnaround that we've got from elsewhere, then that's really the aim.
Well, you definitely sound like you've got a lot of experience in the building a company domain. So what, in your opinion, makes a company innovative, and are there any particular characteristics that stand out to you?
Ooh, innovative as a company. It's a hard one. I guess innovative as a company to me is looking at what's available. So first of all, technologies that may be available, technologies that are mature, manufacturing processes available, maturity in that space as well, and making educated decisions, sustainable decisions. So decisions that make the best sense for the product at hand, or for what they're trying to do. So innovation, you can do any sorts of innovation. In my experience, you can have a tiny improvement on a design that you already have, or you can try and do something totally wildly from scratch. And both of those things you can do wildly wrong. I've seen so many companies, just lose money or go down tracks that are totally unsustainable. I think the core to innovation is doing basically the minimum amount of work you possibly can to get the outcome that you need for your customers. And the outcome you need, it has to be an assessment of the bell curve, so to speak, of the end users. So, engineers are amazing people, but they can polish things forever. And innovation really is holding back the horses, so to speak, that basically just doing the minimum amount of work to basically satisfy the maximum number of end users in the minimum time and cost. And so an innovative company has to really utilize all the resources they have available, or the technologies that they have available. They have to be sustainable technologies. They have to do it in a highly sustainable way, basically looking at what the outcomes are versus the expenditure going into it, and a lot of the time saying no to things, literally saying, okay, that's good, that's great, but really what percentage of the user population does that actually affect? And actually that's not core right now, but we'll put it in the backlog and we'll do it later on, or maybe it's V2. So innovation is hard. Innovation is really, really hard, and that's kind of one of my core skills I've built up over the years, is to help companies see what can be done and what should be done, and that's hard.
That was a pretty great answer. I wasn't expecting it, to be honest. That went in a direction I wasn't expecting.
Good.
Okay, well, as you said, manufacturing is constantly evolving. From your experience, what are the most significant changes that you've seen so far?
I think the most significant change in manufacturing I'm seeing right now is the push for sovereign manufacturing. So sovereign manufacturing is absolutely necessary, in my opinion, just because why not? We don't want to be don't have to be dependent on anyone else if we don't have to be. And I think it's an amazing thing, and it's a fantastic time for businesses like ours. It's also a very challenging time for businesses like ours and anyone else in manufacturing, because unfortunately, and I've learnt this kind of the hard way in the last couple of years, that there is a loss of the manufacturing skills that we maybe once had, unfortunately. So, saying before that I have done quite a lot of designs with products that need to be injection molded, things like that. There's a very small pool of people who know that manufacturing technique, so to speak, even in Australia, not just locally in Perth. And we've got an old 1990s injection molding machine, which is in perfect condition. We bought it from a company who went out of business because they couldn't sell the business. It was an old guy, a plastic injection molding guy who did an amazing job, and he used to make products for the medical industry locally, but he couldn't sell the business because there was not the appetite there to do it. So we were lucky enough to buy one of the machines. It's in amazing condition. It's what we're using to upskill ourselves, and hopefully we'll make some actual products on it one day. But that gives me an understanding of what the condition of the industry is. Even having CNC machinists in-house, there's a challenge to finding those people and their availability. Those tradesmen in our workshop. It seems like they changed the TAFE course, so to speak, from say first class machinist to fitter and turner, I guess in the 90s or early 2000s, and a lot of those people went up to the mines and worked up there rather than doing these really high end aerospace grade CNC machining, things like that. So the pool of available employees is very limited, and so what we're up against right now is we're having to relearn a lot of the skills that have kind of gone, and it's not necessarily a bad thing. Obviously it takes time and effort, and one upside is that we can kind of use the new technologies that are available. So say plastic injection molding, there's a lot of textbooks, and there are people who are consultants who can help with that sort of stuff. Going back to first principles is not necessarily a bad thing, but there's also a bunch of simulation technologies where we can integrate that simulation, the injection mold flow simulation technologies, for instance, directly into our process and build that in from the very, very start. So that's probably the main challenge that we're seeing right now, is the lack of available skills, but it's also an opportunity to probably do it better, and to do it better than we've ever done, and really assess it from first principles and go from there. The second one is the appetite. The appetite's got to be there for local manufacturing. I think cost competitiveness for locally manufactured products is getting a lot better with automation and semi-automation. So some of these pieces of equipment, manufacturing machines, those sorts of things that are available are going to allow us to be cost competitive in a highly competitive world environment. But again, it's got to be built into the process from the very start, and it takes a lot of time and effort to do that. So yeah, it's the appetite's got to be there, and from the consumer as well. I think it is there, but in a hard economy where things are tight, we have to be bang on point with our price, effectively price, and it's got to be feature parity for what can be produced elsewhere. So yeah, it's tough out there, but I think it has to be done, and our society, our industry and our society will be much better for it if we keep going down that path. And I know there's lots of people like myself who are pretty damn passionate about doing it right and doing it for our kids effectively, because there's nothing worse than, in my own brain, thinking about the only thing that we do here in Perth, Western Australia, is pulling dirt and oil out of the ground. We can make that dirt go 10x if we turn it into steel, and if we turn that into some high-end aerospace grade, medical grade CNC machine thing, that goes 100x or 1000x. So, and I've been the engineer that has taken those things to production lines around the world. So why can't we do it here with semi-automation and things like that?
Wow, that was a fascinating conversation with Ayrton Sue, the innovative mind behind Element Engineering. Unfortunately, it looks like that's all the time we have for today. But stay tuned, there's plenty more insightful content from my chat with Ayrton coming your way very soon. So watch this space. I want to extend a huge thank you to Ayrton for joining us today and sharing his valuable experiences and knowledge. And of course, thanks to you all for tuning in. If you enjoyed this episode, please don't forget to like and subscribe to our channel for more exciting content. Until next time, keep innovating. You've been listening to AU Manufacturing Conversations.